So I'm going to hand you over to my POC colleague, Stephen, for a very special event.
Great. Hello, everybody. My name is Stephen Gwynn, and I'm here to present the second annual ADASS Prize for Outstanding Contribution to Astronomical Software. This is a prize we started, I guess, last year, and it's to really recognize the software that has contributed in a meaningful way to astronomy. The way we select the prize is by getting you, the community, the ADASS community, to submit nominations, and then the Program Organizing Committee votes on those nominations. And we want to thank you for your enthusiastic participation. For 2021, the winners of the prize are, the prize is given for IRAF, and specifically it's, well, there was some discussion as to who exactly wrote IRAF. There's an awful lot of people involved, but we narrowed it down to just a core of Doug Tody, Lindsey Davis, and Frank Valdes for developing IRAF. IRAF is a software package that really needs no introduction. It's going to get one anyway. I mean, for many of us, IRAF was our introduction to astronomy software. Developed in the mid-'80s by the folks at NOAO, which is now NOIRLab, and it's been extended by many other institutions over the years. It's become a standard platform for data reduction and pipeline processing for many, many telescopes, both on the ground and in space. And as a sort of objective measure of IRAF's impact, with doing a bit of bibliometrics, as far as the pot can make out, IRAF has contributed over 25,000 papers. So obviously we can't have everybody give a talk at once, but we've selected Frank Valdes, who's going to give us a talk on to accept this prize. Thank you, Frank. Go for it, Frank.
Thank you, Stephen. On behalf of Doug and Lindsey and myself, I want to thank ADASS for this, what I consider a pretty prestigious award. I want to say that in the future, ADASS should definitely tout its own horn. This is the community that represent astronomical software. My organization is going to put out a press release about this. So I want to thank first the Program Organizing Committee for choosing IRAF, and the larger ADASS community. You out there in the ADASS community are the best to recognize success in our field. I also want to thank the organizations that made this possible. And I'll mention how there have been a lot of challenges over time with this, but there have been a few directors and managers with the vision to keep it alive. And that's Kitt Peak National Observatory, which you see Kitt Peak behind me in this background. And so this started with Kitt Peak when it was a separate observatory. Then it became the National Optical Astronomy Observatory, NOAO, for most of its time. And I should also thank the National Science Foundation of the United States for supporting that. And finally, the biggest thanks to the IRAF community. We've had many thank yous, and that's what made this particularly satisfying to us. Many thank yous over time as we supported thousands of astronomers with getting the science done. So thank you. Now let me show you some slides. So here's the list of people. Doug Tody, who is often called the father of IRAF, and he is indeed. It was his initial vision that led to IRAF. Then myself, I wrote most or a large fraction of the science applications that astronomers are familiar with. And Lindsey Davis wrote an area of astronomy, as noted here. And I also want to call out Mike Fitzpatrick, who is not listed on the award, but is central to what IRAF is and has been. He did not want to be recognized because he's on the Program Organizing Committee, but he would be the wizard of the IRAF system. Many people have interacted with him as well. I have there's probably many people who I may miss, but I want to call out a few some of them are listed here. First, George Jacobi is an interesting point that when we were first developing IRAF, the first person who was asked to make some kind of prototype application on the IRAF system was George Jacobi, and he wrote a very preliminary version of what many people who do spectroscopy will recognize, S-plot. The second line, I want to recognize Jeanette Barnes, who was very active in ADASS and in supporting IRAF as the main contact as a support person. Phil Massey, I've had worked with him to write some documents on how to use IRAF for spectroscopic reductions and CCD reductions. And I've had many people tell me that they learned how to do spectroscopy through reading those cookbooks that Phil, I, and Jeanette put together. There are many others and many groups outside of NOAO that contributed parts of what made IRAF what it is. I give special mention to the ADASS group at Space Telescope, which gave, once they adopted it to replace what they were trying to do earlier, added quite a bit of legitimacy to IRAF. So there are many testimonials, and I put a couple here. Many of you may have written me and said similar things. The first one, that IRAF was the tool to use in his everyday work. I like because it was sent to me by a major director of a major observatory. The other common thing, the refrains that we've heard many times over the years is, as other software groups have written software, they often will say, our software is just as good as IRAF, or IRAF's the gold standard that people compare their results against. So all of those testimonials and refrains are very important to us. So I want to start with an anecdote about joining the IRAF group in 1982 out of my postdoc at Bell Labs. And so I came and interviewed and talked to Doug about what the vision was. And the thing I love, first of all, the idea of a national observatory that awards time based on the science and was intended to equalize the playing field for astronomers from small institutions with big institutions. Of course, Kitt Peak evolved into NOAO, and we are now NOIRLab. And then I also like the community mission of IRAF. The intent was to provide software for the community. It was not about writing software specifically for some instrument at NOAO, though that was one of the reasons for doing it. The other thing that I found important was, at the time in 1982, astronomers who came to Kitt Peak to observe would get their data. And if they wanted to use existing software, they often signed up to be in the basement of our headquarters for periods of time to use mainframe software. And that was the way people analyzed and reduced their data. So the concept of IRAF was one of to get people out of the basement and to be able to use what was now becoming more common, mini computers at their institutions. And then the last thing I loved was the technical vision, as it was explained by Doug, of a virtual machine where IRAF provides the core part of IRAF provides a platform on which everything else is built to insulate the applications from the host, and also providing a system and language that was designed and built for application developers like myself. And in the corner, you see Kitt Peak and NOAO called out with their logos, even though we no longer well, the KIPP is still an organization, but it's under NOIRLab. The next thing I could mention was the ADASS, since we're in the ADASS right now. ADASS 1, it was held in Tucson in 1981. And I vividly remember one of our IRAF meetings out on the patio discussing how we could involve more software people outside of our building. And we came up with the concept of holding some kind of conference. And we worked really hard to make sure that it was branded not as an IRAF conference, but a conference for all developers of astronomical systems and software. And Jeanette Barnes, who you see outlined there in the first, as one of the editors of the first volume, was pretty instrumental in getting this ADASS 1 in Tucson held. And I do remember people coming from Europe. This was in November, where it's cold in Europe, but we sat around the patio having drinks in our shirt sleeves. So Tucson was a very popular destination for ADASs. We've had more than one ADASS in Tucson. This screen shows some of the papers from that first ADASS. And my first invited talk was on the spectroscopy reduction packages, which are still in use and still fairly heavily used. And this is based on the fact, on the ability of IRAF to be a very portable system. Another paper I contributed to that talk was on optimal extraction for spectroscopy, and that is also still in use. And Doug and Lindsey submitted a paper on digital photometry of digital images, from which most of the digital photometry tools in IRAF evolved through Lindsey's guidance. I show here a bunch of names. It's a very small set of names, but many of you that have been IRAF users will recognize some of them. I just like to comment on a couple. ImExam was written to provide an interface to graphics and an image display. There's a picture at the bottom. And when I wrote this, I was really surprised how widely it became used. I often could find pictures of control rooms, not necessarily at NOAO, that on the screen you could see pictures of ImExam. So it was used at the telescope for measuring point spread functions or getting some coordinates. S-plot I already mentioned for spectral plotting, similar to ImExam, and it was used by many people, and that's one that people would say it's just as good as S-plot. And so here you can look at some of the words, and maybe some of them resonate with you. So I mentioned that it was a very innovative project, and you got to remember this is back in 1991. Over the years, many buzzwords have come along, but we have to recognize that some of these things, before they were actually assigned a buzzword, were in the thoughts of Doug and the IRAF group. First was a virtual machine, now common in things like Java. The idea of having a host, an underlying host system that would insulate you from the actual operating system of whatever computer there was. Then the programming language for applications developers. And this was a time where Fortran was dominant, but it was not as good as C, for instance, for developing software. So the programming language that was developed by Doug is based on RAT4, which provided something C-like, but it was compiled into Fortran. We still use the subset preprocessor language, but now it gets interpreted into other languages, but it still remains very portable. And as I mentioned, something like the spectroscopy tools that were written in the 1980s, the code is still usable without change. The important thing for software developer and application developer is the libraries, and IRAF has really got libraries and libraries and libraries aimed for science. One of the areas was the concept of image kernels, so that we started with one image format. When the image formats changed or support was added for, say, real-time runtime fits, the code that had been written did not need to be changed because the libraries provided a kind of protection against that. And something that also is sometimes given as a concern that object-oriented programming became more and more commonly used. What's not realized is that IRAF, and I learned the style from Doug, an object-oriented style, and this was using 1980s Fortran. There have been many successes, obviously, over the years. IRAF has been used by thousands and thousands of astronomers all over the world, and it's still used 40 years after the initial design. I'm counting 1981 when the vision of IRAF started. The first release to the world was in 1986. So I consider we have 40 years of IRAF, and it's still in use. The idea of the virtual machine allowed us to port the virtual machine to many different machines. And I list some here that you may remember from history: the VAXes, Cray, and so forth, and even a fun port by Mike to an iPod. There's also been external packages contributed to IRAF, for instance, the STS-DAS suite of tools, Gemini. There have been several other organizations that have written their packages layered on IRAF. That's been a big success for being beyond just NOAO. As I mentioned, IRAF has been used both at telescopes and in offices. At telescopes, not only was it used for evaluating the data, like with ImExam, but there was actually a instrument control package developed to run CCDs layered on IRAF. It's still used in a number of pipelines, and it was adopted by many observatories. Now, many have moved on to other developing their own, but again, IRAF is considered an example of where they want to go. And then, of course, the success is the science. So this graphic shows the growth of publications, scientific publications in refereed journals of papers that mention using IRAF. A common phrase would be data was reduced using standard IRAF tools. This graphic goes up to 2015, but it's continued to go up. So that, in my feeling of our group, is that is a key measure of the success of IRAF, is it enabling the science. As I mentioned about still being used in pipelines, as well as on people's desktops, here's an example of images from an most all-sky survey, the legacy surveys, where the raw data was calibrated by IRAF, and then come from the DECCAM camera on the left and the cameras on top of Kit Peak, Mosaic, and 90 Prime. And they were processed and touched by IRAF at some point in the calibration. Another interesting feature I'd just like to mention is that while most people think of IRAF and the CL as an interactive tool that you run on your desktop, in the pipelines that I've been working with for a while, we run it IRAF in parallel. So we have IRAF sessions that are constantly being created to run modules on a cluster of 40 hosts, and that's how we process the over 1 million DECAM exposures that we just passed that milestone. So I want to talk about the politics and the future. Politics have always been a problem or a aspect of this, and I'm sure everybody in the audience right now will recognize this, that when you're in a software project, there are a lot of politics going on. For IRAF, from the beginning, there have always been voices wanting to kill IRAF, usually over fairly minor cost rationales. For example, in the very early years of development of IRAF at Kip Peak and then NOAO, there were voices that said, why should we spend money on IRAF when we can buy more VAX computers? And so the IRAF project, we in the project have had to deal with these constant ideas that money could be saved by eliminating 3 or 4 IRAF programmers, where the amount of money is some 1% of the budget of the organization. Fortunately, as I mentioned, there have been directors that have understood the value and the vision of providing community software. The language that we used, as I said, in the early 1980s was extremely important to us and has proven one of the successes because that code is still unchanged and still runs. But it's always been an argument that we would hear to the point of saying no new software developer is going to want to learn this language. So that has always been a limitation to expanding IRAF. And another common phrase that you may empathize with, some of you, though most people in ADASS are probably more of the, I want to write the software, was that IRAF is a black box, that people could come and reduce their data from raw data to images and papers without really necessarily knowing every detail that goes on, like how a CCD is actually reduced. The thing to keep in mind that I've always had was that there are 2 worlds of people that use our software. They're the power users and the big organizations. And then there's the rest of the astronomers who may not develop software, may not want to write software, want to just get the science, their workplace that have reduced resources. And that's really where IRAF continues to be important. On the question of, or the point about people wanting to kill IRAF, I had to develop, and we all had to develop the thick skin to say the community will vote with their feet. So people will, when people would say, let's stop supporting IRAF, all the IRAF community out there would come forward and say, we still need this. And I'm very grateful for that. Then I'll say a few comments about the future. As apropos to the idea of who actually uses software, over the last 10 years or so, there's certainly been a lot of move to Python and to Jupyter notebooks and all that stuff that you're all familiar with. But the question is, are we going to make everyone write their own reduction analysis code? In this meeting, the only question I asked was along those lines. If a working astronomer wants to do photometry in this particular system, how do they do that? And the answer was basically boiled down to find somebody who used our system to write photometry software. So I think there's still a need for people to recognize that not everybody wants to write their own software to do their basic astronomy. So that leads to the question of, is it possible for there to be any institution that will support general purpose software development? NOAO had that vision, and despite the challenges, kept supporting it to write this general purpose software. CCD proc to reduce CCD images was used on many different observatories. But when I look at the world, I don't see that. I don't know how that will ever happen, if there's going to be a next generation IRAF where some organization uses their funding to allow general purpose software that's not specifically devoted to their particular instruments. And then to anticipate a question that I'll probably get is IRAF good for the future? And the answer, in my view, is yes and maybe. Yes, in that IRAF, in its virtual operating system that can be ported, can continue to run with the language unchanged, the code, millions of lines of code unchanged for as long as the host system support the virtual machine. The maybe is that support for it, and also life does move on to new systems. There have been politics about IRAF. Some of you may have thought you heard the rumor that IRAF was dead or IRAF was no longer supported. That's mostly a political thing. So I don't know if IRAF is going to be around in 10 years. I think it will be for some institutions. So that's the best answer I can give you to that question. So again, thank you to ADASS and the IRAF communities. And I show a little humor here of somebody writing a cartoon about IRAF and the challenges people had. A big system always has, it takes a while to learn. And with that, I finish with great appreciation to ADASS and open to whatever you want to do, Stephen.